lemonade stand, and he said to the man running the stand, "Hey, bum bum bum, got any grapes?" The man said, "No, we just sell lemonade, but it's cold."
All right, that's garbage. Now it's stuck in your head. You got any grapes? All right, first thing. You see nothing on the hand. You can thank my doctor. That's my cast. But he didn't want you to lose out on education. So my cast is removable so I can write for you, and then I'll put my cast. Isn't that so nice of him? Otherwise, we'd have been shut down. We wouldn't have been able to do any work at all. But what an awesome doctor to give me a solid thing that I can take off so that I can write for you. I know, what an amazing man. If you all want to write him a letter, you just email me and I'll get you his address. All right, first thing I want to do. Homework that's due today. Don't freak out. You've already done it. Knock it off. So this will be the homework week of 5/18 to 5/21. Okay? So last Monday, 5/18. Last Monday, you did something called Le Chatelier's Principle. It was a worksheet. It was found on my website. Okay? You did the first page only. If you remember right, it had arrow like up arrow, down arrow, right arrow, left arrow. Okay? So you did that. That's those points. If you did it, if you attempted it, that's 2 points. Okay? Then Tuesday came along. 5/19. Tuesday. You did a thing with the world's weirdest name. Oh crap, I can't do it. Equabrazole Revazole. Okay, and you did the first page of it. Okay, that was Tuesday. Again, those points. Wednesday, 5/20. Okay, Wednesday, 5/20. You did the equilibrium test, which we are going to grade here in 2 shakes of a lamb's leg. Okay, equilibrium test. If you did that, okay, if you did the equilibrium test, 2 points. And then on 5/21, which was Thursday, there was no homework. So if you title all this up, if you title or total it up, there is a total of 6 points. So go to the item on assignments on Canvas. Assignments on Canvas. It'll be titled Week of 5/18 to 5/21. Enter a score out of 6. More than likely, this is what I'll use the following week. Actually, that'll be in June. The following week to give you participation or not. Okay, there we go. Today's participation, when I go to my computer and mark attendance, will be the homework for 5/11 through 5/15. And most of you, I've updated my grades. My grades are looking pretty for some of you. And I've already done in this assignment. So all I'm going to do is go down my roll sheet, and if you didn't do this, you're getting a non-participation. Okay? So that's how the homework works. Okay? Next thing, pull out your test. Pull out the test, man and woman. Here we go. Now, on this test, for lack of better words, the chemistry, which is my 0, 1st, 5th, and 6th period. If you're in one of those classes, the test has a total of 50 points for you. 50 points for you. If you're in my chemistry 10-12, which is my 2nd and my 4th period, there are 36 points possible for you. So please keep track of your points. Once we're done grading, you're going to go to my website and you'll see something like this. Okay? And it's called Chemistry Percentages for the Equilibrium Test. So this is period 0, 1, 5, and 6, and you'll go, okay, I missed 10, I get an 88%. That's how it works, and you'll enter the 88 in the text box. My Chem 1012s, My Chem 1012s, you have a different one. It says Chemistry 1012, percentages for equilibrium test. And again, you'll go 7. I got an 88. Okay, so those will be on the website, on the Bomber RHS website. All right, here we go. Keep track of your points. All the multiple choice ones are 1 point each. So here we go. Number 1 is C, and you're already like, dag, nabbit, I'm in the hole. That's 1 point. 2 is B. B, baby, bodacious bananas. 3, delicate dogs. Number 4, I started to show my work. You got C cubed, D squared, B squared, A squared. I plugged in the numbers, ended up being 27 on top. 9 times 4 on the bottom, which is 27 over 36, which is 3/4. So the answer is 0.75. B. I think 5, number 5, some of you, like it said, add a catalyst. Well, a catalyst makes it go faster one way, therefore it makes it go faster the other way, so in the end, really no change. Okay? 6, D, delicate dandy. 7, E, elephant. Now, not all of you had problem 7, I don't think. Yeah, you got to do the problems you have. Grade the ones you had to do. Number 8, D, dandy. 9, catastrophic cat. 10, delicious devils. Oh, I hate deviled eggs are gross. 11, carpet. 12, anteater. 13, cat. 14, there's another cat. Got a couple cats running around. 15, more cats. Way too many cats. 16, think we need to get rid of some cats. 16 cats. 17, holy cow. Now, I know some of you, if we had done the bubble sheet, you'd have had all these in a row. C, 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 and you'd have been freaked out and thought you were doing wrong. 18, baby. 19, baby. 20, baby. Okay? So every one of those was 1 point. Every one of those was 1 point. Okay? So moving on. Let's see, number 22. Number 22 is 6 points. So I'll give you a point for writing the equation. I really, really hope you did the AQs, the S's, all that stuff. +2, -2, you got to do all that. Ions, disassociates. Then you write the expression for a point. Okay? Remember the products over reactants, solids die. Solids die. Then they gave you grams and they were messing with you. I went back and added up magnesium sulfide. It's 24 and 32 and I got 56. So that's 0.339 moles. And I was really nice to you. I gave you 1 liter. So when you divide, remember, its brackets are molarity. Moles divided by liters. And I was really nice. I gave you 1 liter so it doesn't mess up the number. So this 0.339 belongs to him. Well, since there's a 1 out front, it belongs to him. Since there's a 1 out front, it belongs to him. So essentially it's 0.339 times 0.339. The answer is 0.115. 2 points for that. So 2 points for the answer. 1 point for turning into moles. 1 point for turning into molarity. So that's 2, 3, 4. 1 point for the expression. That's 5, and 1 point for the equation. That's 6 points. You figure out how many of the 6 you earned. Okay, moving on. 23. Some of you didn't have to do 23. Merry Christmas. Disassociate. 1 point. Bad teacher. Bad teacher. Expression. 1 point. So we've had 2 points. They gave you K. They gave you K. You don't know BA, but since they're in a 1-to-1 ratio, if you don't know him, you don't know his kissing cousin. So it's X. X times X is X squared. So now to solve it, you take the square root of both sides. So showing some kind of work gives you a point. Okay. So I took the square root and I got this number. Now remember, brackets mean molarity, which is moles divided by liters. And I wanted the answer in grams. So mole on the bottom, grams on top, and I added up barium carbonate and I got 170 or 197. Now if I quit right here, I would be in grams per liter. I don't want no liters. I just want the grams. So I times it by 2 liters. Liters die, 0.028. 6 points, 2 for an answer, 1 for some fancy work here, turning into using grams, 1 for some fancy work here, 1 for expression, 1 for equation. 6 points. Okay? Problem 24. Problem 24. Every arrow is 1 point. Every arrow is 1 point. If you add in 2, it goes up, shifts to the right, products go up, reactant goes down. So 1, 2, 3, 4 points. B, coolant. Coolant always goes towards the energy. So it's going to shift to the left. The guys on the reactants are going to go up. The product's going to go down. That's 4 more. 4 more. If you increase the pressure, it goes to the side with the fewest. Well, on the right, there's 2, and on the left, there's 4. So it shifts to the right, so the products go up, reactants go down. 4 arrows, 4 points. Last one, remove H2. If you remove some, this side's going to come over to help out. This will go up, and that'll go down. Okay, 4, 4, 4, 4. And 25, do you remember how to do stoic? That's all it is. Do you remember how to do stoic? That number goes there, stoic over. So, you have to get out of grams. O2 adds up to 32, so that's a point for getting out of grams. The mole ratio is head over tail, 4 over 3, that's a point. Then you got to turn it back into grams. NH3 adds up to 17. And the answer is 19.5 for 2 points. Okay, I think that's it. All right, so there are 20, what would I say? There's 50 points possible for chemistry, 50 points. So you'll figure out how many you missed, and you'll find your percentage, and you'll send it to me. Chem 1012, 36 possible. Boom, boom. This stuff's on the website, so I'm not going to sit here and waste your time. Okay, you already think I am. Next thing. You need some notes. So pull out your notes that you did on acid base. We should have had 5 properties of an acid and 5 properties of a base. Today, I want to do a few definitions. Okay? The very first definition of an acid and a base is by a guy named, I love his name. This is such an awesome name. Well, his last name is Arrhenius. So this is called Arrhenius's definition. Arrhenius in his first name, Savant. Just think, you should name your kid that, Savant, whatever it is. Savant Schaefer. Okay? Savant Arrhenius. So this is the Arrhenius's definition of an acid. Here's what he said. First of all, you got to learn this. Remember polyatomic ions? Those are the things on the back of your periodic. Poly means many. Atoms. This means charge. So polyatomic, like we've done this many times. You've used sulfate. You've used nitrate. I mean, that's no big deal, but there's one you kind of new to you now. You need to know this one. Okay, there's a polyatomic ion called H3O positive 1. This is called hydronium. If you look on the back, you'll find it's one of the few positive ions. Hopefully it's on the back. Okay, hopefully it's on the back. All right, here's what Savant said. He said acids form hydronium ions in water. Some books call it an aqueous solution. It's water. Now, you're going to see in a moment, I don't really like Arrhenius' definition. He just tells you what you get. There's another guy we'll do in a moment. He tells you what's happening. Okay? So, here's an example. If you take hydrochloric acid, that's the acid in your tummy. Okay? It's a very abundant acid. Hydrochloric acid. And if you pour it into water, side note, never, ever pour water into acid. Never. Hold on, I got it the other way around. No, you can't. Acid goes into the water. But anyway, doesn't matter. I got all screwed up there. So you're going to pour this acid. Now look what Arrhenius said. What did Arrhenius say? Arrhenius said we're going to get hydronium. So check this out. There's our hydronium. Okay. That's actually AQ2. Okay. That's a liquid. Check this out. Smart student, can you see what happened? Okay. But all you need to know, this is Arrhenius' definition right there. Whoop, whoop, boop, 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 boop. Acid, water forms hydronium. Okay. Acid and water forms hydronium. Next up. Staying with Arrhenius. Staying with Arrhenius. Okay. Arrhenius' definition of a base. Okay, Savant Arrhenius. Gotta love that name. He said bases form. Now here's another polyatomic ion. You had to know hydronium. Bases form hydroxide ion. Now let me stop. Hydroxide looks like this. OH minus 1. It's on the back of your periodic. Bases form hydroxide ion in water. Okay? Acids form hydronium. Bases form hydroxide. Now remember, I'm not a big fan of Arrhenius's, but you got to know it because it's kind of telling you kind of what you get. So you may not know it, but NH3 is a base. And one of the ways we know this is ammonia, and we know we clean with ammonia. We clean with ammonia, so it is a base. Bases are cleaners. This time, NH3 became NH4. There's your hydroxide. AQ, AQ. Okay. Water, AQ, and liquid. All right. There it is. There's your key. Do 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 do. Okay. Arrhenius done. Now I'm going to lead into the next guy, but you can already. The next guy is going to tell you what happened. But if you're a halfway intelligent person, you can see what happened. How come that hydronium was formed? What went on to form it? What went on to form that hydroxide? Okay? What went on? So the next definition is called the Bronsted definition. In some books, you'll see Bronsted and another guy, Lowry. They work together. But we're just going to call it the Bronsted definition of an acid. Okay? Now watch this. Just an example. That's vinegar. It's called acetic acid. That's vinegar. If we put it in water, Well, we already know. We already know that acids in water form hydronium. Look what happened to the acetic acid. It changed. There's your hydronium. Okay? So what do you think Bronsted's going to say? Bronsted says a substance that donates an H positive. Now an H positive is weird. It's called a proton. Hydrogen has one electron and one proton. In order to become positive, the electron disappears, so the only thing left is a proton. So H positive is synonymous with the proton. Don't let that bother you. Okay? So a substance that donates, that's the key word, donates an H positive to another substance. Acids donate H's. I don't care how you say it. H's, H positive, proton. It's all the same stupid thing. When you pour lemon juice in your eye and you scream like a little baby, that's all the H positives that are coming off of the acid and hurting your eye. If you eat Warheads or Sour Patch Babies, and then it's really sour in your mouth, it's the number of H's reacting with your taste buds. All right, so if you look here, there's an H at the end. Now it's gone. If you go back to my example way here, HCl, where'd the H go? He donated. It's like that drive-through lane at Goodwill, and you donate your H. It's a Goodwill that only takes H's. Okay? Bronsted of a base. If acids donate, bases, you should already know, you should be so far ahead of me. Bases are a substance that accepts an H positive, again, which is a proton. Don't let that bother you. H positive, same thing as a proton. From another substance. Okay, you may not know it, but I already told you NH3 is a base. How do you know it's a base? Watch this. That right there is called nitric acid. So if he's truly an acid, what's his one goal? He wants to get rid of that H. He's like, you're out of here. Okay? If this is truly a base, what's his one goal? And he's like, hey, come over here, baby. I like you. Bases accept. So what's going to happen is this H positive is going to come over here. You get NH4 positive because he gained an H positive. And the NO3 lost an H, so that's -1. Acid gave, base accept. Okay, I'm about at the end of my time. I want to show you one more definition, then we're done. Okay, the final definition that's an I, amphiteric, or some books call it amphoteric. Ampha, for lack of better words, means both ways. Like an amphibious vehicle can go on the land and it can go on the water. Product means proton. Acids donate protons, bases accept, and here's one that does both ways. Both ways. Well, an example, what I'm talking about here is water. Is water. Why did I do that? Okay, check this out. I want to show you a weird equation. That's water. And you're going to think I'm weird here, but that water is going to hook up with this water. You're going, what in the world is he doing? Okay? I'm color coding them for a reason. Okay, think of water as a hoe. Water's a hoe, H-O-H. So see this red water? What did it do? If you look from here to there, it gained an H. This red water is acting as a base. Look at this purple water. Think of water as H-O-H. It lost an H. All that's left is O. It went from a hoe to O. Okay? So this guy is acting as an acid. And I already said this guy is acting as a base, yet they're both water. If you're drinking a cup of water right now, this is in there. Now, what you hope in your cup of water is that there's the same amount of acid molecules as there are base molecules. Therefore, your water will be neutral. More than likely, your water is slightly one way. It's either acidic or slightly basic, which means acidic, a few more acids, a few more of these than these. Okay? So water, any substance, and water's the main one, that has the ability to act as an acid or a base is said to be amphoteric or amphiproduct. There are other substances out there besides water, but not a lot. Water can go either way. It can be an acid, it can be a base. It depends on the situation. Okay? Now that's the notes for today. I'm running a little bit long. There's no homework tonight. But please, please, you have two things to enter. Enter your homework for the week of 5/18 to 5/21. And 2, enter your equilibrium test score. So there's 2 spots on Canvas. All right, peace.